Okay, so let's look at an example of solving for KSP. So I'm going to write out an example and we'll work through it together. So I'm going to say exactly 0.133 milligrams of silver 1 bromide will dissolve in 1.00 liters of water. What is the value of KSP for silver 1 bromide? Okay, so the first thing we need to do is we need to write the solubility equilibrium. So silver 1 bromide is going to break apart into its ions. So I'm going to have silver 1 bromide, which is solid, and it is going to break apart into its ions, Ag plus 1 aqueous plus Br minus 1 aqueous. So that's the equilibrium. Now we need to solve for the KSP using an equilibrium table, just like we've done everything else. So that's the reaction, initial, change, equilibrium. So what goes here is the initial concentration of, what we're solving for is the KSP, and we know what the molarity is based on the grams per liter. So the first thing we need to do is use the information from the problem. So we need to convert 0.133 milligrams of silver bromide per liter to moles per liter, because that is what goes in our equilibrium table. So let's see. So we have 0.133 milligrams. So I'm going to say 0.133 milligrams. And I know there are 1,000 milligrams in 1 gram. And I know the molar mass just by looking up the molar mass on the periodic table of silver and bromine and adding them together is 187.77 grams in 1 mole. So now what I've done is convert milligrams to grams and grams to moles, and it's in 1 liter. So however many number of moles this is, it's going to be moles per liter. That's my molarity. So this is going to give me 7.08 times 10 to the negative 7th molar. So that is, well, it's actually moles, but I know it's per 1 liter, so this is the concentration. So that's what's going to go. That is the molar solubility. So when we're solving for the KSP, the molar solubility, that's the amount that is going to dissolve. So this is a 1-to-1 ratio. Remember, this is a solid, so this is not included in the equilibrium. But so we don't have any of this, any of the silver, any of the bromine. This is plus X, X, X. So because this is a 1-to-1 ratio, if we know that 0.133 milligrams of silver bromide dissolved, if this wasn't a solid and we were allowed to put things in solids and liquids, it would be 0.133 milligrams per liter, which is 7.08 times 10 to the negative 7th molar. This is the concentration of silver bromide that broke apart. So if 7.08 times 10 to the negative 7th moles per liter of silver bromide dissociated, which is what this says, that's how much dissolved, it would produce 7.08 times 10 to the negative 7th moles per liter of silver 1 ions and 7.08 times 10 to the negative 7th moles per liter of bromide ions. So essentially what this is, this molar solubility, is it's X. It's the amount that's going to ionize. So something that's important to pay attention to here is these are the same number because this is a 1-to-1 ratio. So if 7.08 times 10 to the negative 7th molar silver bromide ionized, that's how much of each of these ions was produced. So we can say X equals 7.08 times 10 to the negative 7th molar. That's what X is. So the KSP is essentially X squared. KSP equals the concentration of the silver ion times the concentration of the bromide ion, which is X times X. KSP equals X squared, which is 7.08 times 10 to the negative 7th squared, which ends up being 5.02 times 10 to the negative 13th. And remember, there's no unit here for the KSP because this is a ratio of ionized to unionized. It's how much broke apart. So when we're talking about KSP, these are very, very small numbers because these are only slightly soluble, mostly insoluble compounds. So only 5.02 times 10 to the negative 13th broke apart compared to how much stayed together for silver bromide, silver 1 bromide. So we used the milligrams and the liters to go from regular solubility to molar solubility, which is what we need for the equilibrium table. The amount of silver bromide that dissociated is the amount of silver ions and bromide ions that were produced. Because the KSP is X squared, we just squared that amount to get the value of KSP for silver 1 bromide.